In this video, we're going to talk about ionic compounds in aqueous solutions and net ionic equations. So, when we take an ionic compound, which is comprised of a metal and a nonmetal, in solution, when we dissolve that in water, it tends to dissociate into its ions. So it doesn't stick together, it dissociates into its individual ions. So, in solution, we actually have Na plus aqueous and Cl minus aqueous. So this dissociates to give individual ions instead of sticking together. And in actuality, this equilibrium for ionic compounds lies really far towards the dissociation into the individual ions. So most of the ionic compound in solution is not still hanging out together, it is dissociated. So to have some notes here, we would say ionic compounds tend to dissociate when in an aqueous solution, and covalent compounds tend not to dissociate. So there are some exceptions to this, and that is acids and bases. And we're going to cover that when we get to a later chapter. So the summary is that ionic compounds will dissociate to give their ions, and covalent compounds will stick together in solution, so they will not dissociate. Okay, so we're going to look at now net ionic equations, which is really what's changing when ionic compounds react with one another. Okay, so we know they dissociate in solution, so let's take a look at the combination of lead nitrate aqueous plus lithium iodide aqueous. So this is going to be, I'm going to draw it like this, in equilibrium with, and I'll keep our products in red, lead iodide, which is a solid, okay, plus 2 lithium nitrate aqueous. So if we look at this chemical equation, all these ionic compounds are going to dissociate in solution to give their individual ions. All right. So what we can see is that here nitrate ions are aqueous, and here in my products they're also aqueous. And I will have lithium ions aqueous, and here in my products they're also aqueous. Okay. Let me find another color here. Let's see. It's kind of an ugly color, but we'll use it. So the lead, though, has gone from lead in the aqueous form to lead in the solid form, and same with the iodide. So lead and iodide have changed to make lead iodide solid. So this is called a precipitation reaction, when you have two aqueous ions form to make an insoluble compound that falls out of solution. And in the next video, we'll talk about different classifications of reactions, but we'll just write here so we can remember. Precipitation reaction. So to really see what looks different and what looks the same, we're going to write all of the components out in their aqueous ionic form, so what they really look like dissociated in solution. So the net ionic equation for this reaction would look like lead 2 plus aqueous plus 2 nitrate ions that are aqueous plus 2 lithium ions that are aqueous plus 2 iodide ions that are aqueous. So those are my reactants, and my reactants are all ionic compounds that were in the aqueous form, so they dissociate into their individual ions. Now, for my products, I have lead iodide, and that's a solid, so it is not going to dissociate because it's in the solid form. But I still have 2 lithium plus ions, aqueous, plus 2 nitrate ions, aqueous. Okay, so this is the whole equation split into those ionic counterparts. So what you do is you look at your reactant side and your product side, and you're going to cancel out. So I'm going to put here reactants, here are our products, anything that's the same on both sides. Okay, so if I look through here, I've got 2 nitrate ions on the reactant side right here, and I have 2 on the product side, so I can get rid of those. Same with the lithium ions. Oops, I dropped my charge there. Let's put our charge on our lithium ion there. So I have 2 lithium ions, so there's 2 lithium ions aqueous on the reactant side and 2 on the product side. So your net ionic equation is going to be what is different. So really what happened is lead aqueous combined with iodide aqueous to make lead iodide aqueous. So on the next page we're going to write that net ionic equation. So my net ionic equation for the reaction, what's really happening is lead 2 plus aqueous, it's crazy hue, plus 2 iodide aqueous goes to make lead iodide solid. Okay, so only the things that are changing from reactants to products are going to be involved in my net ionic equation. Those other compounds, lithium plus and the nitrate ion, so these guys will just both be aqueous on both sides. Those are called spectator ions, okay? So they're in solution, floating around, but they're not part of the chemical reaction that's happening. So here's a picture I got from the internet. You can see the references right on it in the middle there, so from Fundamental Photographs. So there's 2 beakers here, and they each contain a colorless, clear solution. So one beaker would be lead nitrate aqueous, and the other one would be lithium iodide aqueous. And so they're clear and colorless. When we combine them, we see this yellow precipitate form. So that's the solid that you're seeing here. So this guy here is my lead iodide solid. Oh, I guess I should have color coordinated it and used yellow, but that was an ugly color. So that yellow is awesome of the precipitate. The yellow of my pen is pretty gross. So this is what happens when you see a precipitation reaction. So that net ionic equation we wrote on the previous slide, that's for a particular precipitation reaction, this one.